Hello, everyone. This is a question on heat energy in physics. Let's look at the question. To solve this question, you need the knowledge of heat energy in physics, latent heat also. You need the knowledge. But let's look at it together and let's solve it. There's a way I solve it in secondary school then I will use that method. Then maybe that method may be of good help to you. Let's look at it together. I said, calculate the heat required to raise 20 grams of ice at minus 5 degrees Celsius to steam at 100 degrees Celsius. So it means we are looking at the heat required for ice to actually melt to a point, it become vapor at 100 degrees C. Now, there are things I do when I solve this question. What I do is that I draw a diagram to show the changes of the ice from one state to another. So there's a point where the ice did not change state. At that point, then you know that we have to be specific heat capacity that will be added to that point. Where you see a change of state, then you should know that it will be at a constant temperature. Then it will be a latent heat. So we are going to look at it. This is ice now. This ice is as it has what? Minus 5 degrees C. Now, when it will be melting little by little, still in the form of what? Still in the form of what? Of what? When it's melting, when it is being added, when it's melting, it turns to 0 degrees. That means that there's a change in temperature, but there's no change of state. So it will be ice forming ice. Little by little, is forming ice at 0 degrees C. So here you try to do MC theta. This C here is the specific heat capacity of what? Of ice, which is what? 2.1 joule per gram per Kelvin. Is that okay? 2.1 gram joule per gram per Kelvin. At this point, when it's changing to water, so there's a change of state now, so it will be a latent heat. Ice to water is a latent heat. So there will be a constant temperature, latent heat of fusion of ice. Latent heat of fusion of ice. And here, the latent heat, the specific latent heat of fusion of ice is 336 joules per gram. 336 joules per gram. Now, the water, now boiling now, is still in the state of water at 100 degrees C because it is being added. Now there is a change of temperature because the water is now boiling. So there's no change of state. Now notice, anytime there is no change of state, there will be change in what? Temperature. So you have MC theta. Here we use the specific capacity of water, which is 4.2 joules per gram per Kelvin. 4.2 joules per gram per Kelvin. Then the water forming steam. Now there's a change of state. The water forming steam. So at the constant temperature now, the water forming steam now, that is perceived latent heat of vaporization. ML, let's call it V. This is what? 2260 joules per watt per gram. This is a specific latent heat of vaporization of water, which is another place you can call it specific latent heat of steam. So we are going to use this to solve our question. So here we have H1, here we have H2, that is E1, E2, then we have H3, then we have H4. After finding those, the H1, H2, H3, H4, we are going to add everything together. So we have H1 equals to what? MC ice theta. MC ice theta. So there is a change in temperature. So you are going to have, what is mass? 20 times 2.1 times change in temperature. That is 0 minus 5. 0 minus 5, that will give you 5. So you find your value. We are still coming to that. Let's go for H2. So let's do ml. That is 20 times 336. You find your answer. We are coming to do that. H3. MC water. Change in temperature. So you are going to have 20 times 4.2 times 100. We're going for that. Then H4, ml vaporization of water. That is 20 times 2260. So let's find the value of each, and we are going to, add it up. 20 times 2.1 times 5. This give me 210. Then let's do the next one. 20 times 336. It gave me 6720. Please put the unit joules. Then 20 times 4.2 times 100. This gave me 8,400 joules. Then 20 times 2260. You have 45,200 joules. So the heat required will not be heat total. We are going to add this up. So we are going to have 210 plus 8,000 plus 6,700 plus 8,400. So let's do 210. We are adding it one after the other. 210 plus 6720 plus 8400 plus 45200. So that gives us 60,530 joules. 60,530 joules. You can put it in standard form, 1, 2, 3, 4. So you have 6.053 times 10 raised to the power 4 joules. So this is the amount of heat required to raise 20 grams of ice to steam at 100 degrees C. So for ice to form steam, the heat required is 6.053 times 10 raised to the power 4 joules. Thank you, and follow for more updates. Kindly subscribe to my YouTube channel, and when I drop new physics question, you'll be the first to see it. Thank you. Bye bye.